Hi, everybody. This is topic number 5, energy. We should know potential energy is stored energy, whereas kinetic energy is energy of motion. The law of conservation of energy states that energy can neither be gained nor lost. Uh, it only changes from one form to another. Heat is a transfer of energy from higher temperature to lower, or we simply say hot to cold. Temperature is a measure of average kinetic energy. So the higher the temperature, the higher the kinetic energy. Number 5, we're going to explain down below. 6, exothermic, give off energy. They cause the surrounding to get hotter. So a thermometer will rise. In an endothermic reaction, energy is absorbed. It absorbs it from the surroundings. So a thermometer will lower. Solid to liquid has to absorb energy, so it's endothermic. So a liquid has to give off energy when it freezes, and that would be exothermic. A heating curve can show kinetic and potential energy. Remember, this is the solid phase. Since the temperature is going up, kinetic energy is going up. As it melts, the substance absorbs energy to break the attractive forces, so the potential energy increases. In the liquid phase, the temperature goes up, so the kinetic energy goes up. When it boils, again, energy is stored to break apart the attractive forces, so the potential energy increases. And then as a gas, the temperature will continue to rise, and the kinetic energy will increase. Onward to topic 6, the periodic table. Elements are arranged by increasing atomic number, which is the number of protons in the nucleus. The atomic mass, which is the upper number in the symbols, is the protons plus neutrons. Isotopes have the same atomic number, but a different atomic mass. Elements can be classified as metals to the left of the step, nonmetals to the right of the step, and metalloids, which are on the step themselves. Elements are arranged into periods and groups. Periods are horizontal rows. Groups are vertical columns. If you are in the same group, you are chemically similar. If you are in the same period, your electrons are going into the same principal energy level as you go across the periodic table. You have to know the names of the groups. Group 1, Group 2, Group 17, and Group 18. Fluorine is the most reactive nonmetal. Francium is the most reactive metal. Lithium, 3 protons, so 3 electrons, 2 in the first shell, 1 in the second shell, which is the principal energy level. Carbon is also in the second period, 6 protons, 6 electrons, 2 in the first shell, and 4 in the second. So we see that as you go across period 2, they are both filling the second principal energy level. You must know the trends of the properties as you go across a period and down a group. As you go down a group, the sizes get bigger as you fill more and more principal energy levels. That causes the radius to increase. It's easier to remove an electron, so the ionization energy goes down, and you don't hold your electrons as easily, so your electronegativity goes down. And since the electrons are lost easier, your metallic character increases, because metals lose electrons. So you should be able to figure out the same trends as you go across a period. And then finally, some elements may exist in 2 or more forms. Carbon can be graphite and diamond. They have different properties. Although they're the same element, they have different properties, and these are what we call allotropes. So that finishes topic 6. Onward to topic 7. Topic 7 deals with moles and stoichiometry. A compound is a substance composed of 2 or more different elements chemically combined. Chemical compounds can be represented by a formula, which we have to be able to put together using table E if it's polyatomic, or if it's a metal, nonmetal, balancing charges, or 2 nonmetals, being able to tell the formula's name by the subscripts given. So empirical formulas are simplest ratio. Molecular formulas are the actual ratios. And a structural formula shows, like we did in organic, sticks for the bonds. All chemical reactions show a conservation of mass. So we have to balance a chemical equation. The coefficients can be used to determine a ratio from one substance to another. The formula mass is the sum of the atomic masses, which we've done. And then percent composition is just taking one part of the formula and put it over the total. Types of chemical reactions we need to know: synthesis and decomposition, single and double replacement. So C4H10 has an empirical formula of, so we can divide by 2, so C2H5. If I asked you to balance this equation, we should know C3H4, since we double and subtract 2, would be propyne. If it's a combustion reaction, it reacts with oxygen to form carbon dioxide and water. And to balance the equation, since I have 3 carbons, I put a 3 in front. 4 H's, I put a 2 in front. I now have 6 plus 2, 8 oxygens, so I put a 4 in front. 1 is understood. If I have 2 moles of C3H4, it will produce, or produces, how many moles of CO2? Since I double the 1, I have to double the 3, and it will produce 6. If I have 4 moles of C3H4, it will produce 4 times as much, so 12 moles of CO2. What is the percent by mass of carbon in C6H6? So I look on the periodic table, carbon weighs 12, so 6 times 12 is 72. H's weigh 1, so 6 times 1 is 6, so a total mass of 78. The mass of carbon would be the 72 over the 78 times 100. And if we get a calculator out, 72 divided by 78 times 100 is 92.3%. The math unit we're going to hit during the review in school much harder later on. So we're going to finish tonight or today by looking at topic 8. Topic 8 are solutions. A solution is a homogeneous mixture of a solute, which is dissolved, in a solvent, which does the dissolving. Ionic substances can dissolve in polar solvents. So ionic substances are metal and a nonmetal. They form positive and negative ions. And the positive ion will be attracted to the negative end of a polar molecule. So if the polar molecule is water, the positive ion will be attracted to the negative oxygen atom of water. Concentration can be expressed as molarity, we have to be able to do, percent by mass, and parts per million. All of these equations are on the back of the reference table. If we add a solute to a solvent, the boiling point will increase and the freezing point will decrease. So if you add salt to water, water will boil higher than 100 degrees and freeze lower than 0 degrees. A saturated solution is in equilibrium, so the rate of crystallization equals the rate of dissolving. So NaCl, solid, NaCl, liquid, are compounds. But NaCl, aqueous, is a mixture. which is a solution. We have to be able to work a molarity problem from the back of the reference table, along with percent by mass and parts per million. So that pretty much covers solutions. We also have to look at table G, which we've done a couple of times. So that covers the video lecture for today. You have one more for tomorrow, and that will finish this book. We have our test on Friday, so it's important to not just read and do what I do here, but to also understand what it is that you are reading. So if you need any help, just ask me in class, and we will talk to you later. Have a great night.